Welcome dear students in MSc-II Organic Chemistry class. As per our previous discussion with Perhydroanthracene molecule, the fifth one isomer of Perhydroanthracene is Cis-Syn-Cis. We know that A, B and C rings of Perhydroanthracene are connected in this way, and nomenclature we know that is carbon number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So first word represent cis word represent AB ring fusion is in cis fashion. So I suppose draw here dot on carbon number 11. If it is cis condition, AB ring fusion is cis condition, then obviously carbon number 12 also have a dot. Then middle syn word represent AC ring fusion, as carbon number 11 have upward direction hydrogen, means dot is there. So carbon number 14 also have a dot, then syn condition is satisfied. Then last cis word represent BC ring fusion, means carbon number 14 and 13 they are in cis condition. Carbon number 14 have dot, so carbon number 13 also have such type of dot. Means this molecule AB ring fusion is in cis fashion, AC ring fusion is in syn fashion. Carbon number 11 and 14 is in syn condition. Cis word represent BC ring fusion, means carbon number 13 and 14 they are in cis condition. This particular molecule is Cis-Syn-Cis Perhydroanthracene. This molecule have such type of two plane of symmetry, therefore this molecule is a meso compound and optically inactive compound. Important thing is the chain conformation. While drawing the chain conformation, we first of all draw here the middle ring in chain conformation, that is B ring in chain conformation. This middle B ring having carbon number 11, this is carbon number 12, this is carbon number 5, this is carbon number 5, this one is the 13 carbon atom and this one is the 14, this one is the 10, like this. So carbon number 11, see this carbon number 11, this carbon number 11 having this dot represent hydrogen is present in upward direction. So hydrogen is present in upward direction, means axial hydrogen is present at the carbon number 11. Carbon number 12 also have this dot, means hydrogen is present upward direction. Here it is present, it is in upward direction, means equatorial position, like this. So remaining position for carbon number 11 is a equatorial position, like this, and for carbon number 12 remaining position is a axial position. Just joining of these two positions in this way. This is carbon number 4, this is carbon number 1. 1, 2, 3 and 4, like this. So this is a ring. Here we draw A ring. Next is carbon number 13. Carbon number 13 have such type of upward direction hydrogen, means equatorial position hydrogen. Similarly carbon number 14 also have upward direction hydrogen, but here it is axial. in this way. So remaining position, see the remaining position with respect to the of these positions. In this way. This is the same. In this way, we can draw the chain conformation. So, joining of these like this. So, joining of these, we get a seeding A, B seeding fusion. But when we consider this particular carbon number 4 and the carbon number 6, this carbon number is 7. They have a lot of 1,3 diaxial interaction. Lot of 1,3 diaxial interactions as compared to the other conformations. And therefore, energy content. The energy content of this molecule is very important. The first point is the AB ring fusion. AB ring fusion is in cis fashion. And we know that if it is in cis fashion, then there are 3 gauge butane interactions. Similarly, BC ring fusion. Here, BC ring fusion is also in cis fashion. So, ultimately 3 gauge interactions. So, total 6 gauge butane interactions are there. And energy is supposed to be 6 gauge interactions are there. So, energy content is supposed to be for 6 gauge interaction. Then it is found to be 5.4 kilocalorie per mole. It is supposed to be considered only 6 gauge interaction. Then energy content is 5.4 kilocalorie per mole. But unfortunately, in this particular molecule, there are lot of 1,3 diaxial interactions are present in carbon number 4 and carbon number 6 or 7, which are absent in other conformations of Perhydroanthracene. This additional 1,3 diaxial interaction have energy content of 2.2 kilocalorie per mole, and therefore total energy of this conformation is found to be 2.2 plus 5.4, and it is found to be 7.6 kilocalorie per mole. And this much amount of energy is the highest energy content among the all different conformations of all 5 conformations of Perhydroanthracene. Important point which is asked in an examination related to this Perhydroanthracene is that the epimerisation of Trans-Syn-Trans Perhydroanthracene 4-ONE is not easily takes place. Epimerisation is not easily takes place under basic condition into Cis-Syn-Trans Perhydroanthracene 4-ONE compound. Why? Means Epimerisation of Trans-Syn-Trans Perhydroanthracene 4-ONE is not easily takes place into Cis-Syn-Trans Perhydroanthracene 4-ONE compound under basic condition. Why? The reason behind it is only related to the energy content. What is that? Suppose we consider the Trans-Syn-Trans Perhydroanthracene 4-ONE, this compound. The compound is like this. A, B, C. First transfusion means 11 and 12 carbon atoms are in trans condition in this way. Carbon 1, 2, 3 and 4 carbon having this double bond oxygen, 4 OAB, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So trans AB ring fusion, trans middle AC ring fusion syn, AC ring fusion syn like this. Then BC ring fusion is in trans fashion, BC ring fusion is in trans fashion. The molecule is like this. So for this molecule, so this is a correct representation for this molecule, that is Trans-Syn-Trans Perhydroanthracene 4-ONE. Carbon number 4 having double bond oxygen. So when we consider the energy content, AB ring fusion for this molecule is found to be trans. So 0 gauge metal interaction. Second, BC ring fusion is also in trans fashion. Trans. So again have 0 gauge metal interaction. So net energy content, total energy content for this conformation is found to be 0 kilocalorie per mole. Means it is more stable, 0 kilocalorie per mole. What about this Cis-Syn-Trans? This conformation can be drawn like this: 11, 12, this is 10, 1, carbon 1, 2, 3, 4, 4 having this carbon oxygen. This is carbon 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So cis means AB ring fusion is in cis fashion. Means suppose I drawn here dot over carbon number 11. Ultimately carbon number 12 also have such type of dot. Means cis ring fusion. AC ring fusion is in cis fashion. AC ring fusion means carbon number 11 and carbon number 14 are in cis condition, in syn condition. So ultimately they also have such type of dot. Lastly, BC ring fusion in trans fashion. BC ring fusion means carbon number 14 and 13 they are in trans condition. Means this only dot over this carbon number 14, carbon number 13 does not have any dot. Trans condition. So this is the correct representation for this molecule. So whenever we talk about this energy content, then AB ring fusion is found to be cis fashion. And we know that for cis condition there are 3 gauge metal interactions. Second thing, BC ring fusion is in trans fashion. Therefore 0 gauge interactions. Means total energy is equal to 3 into 0.9, because only 3 permuted reactions. 2.7 kilocalorie per mole. 2.7 kilocalorie per mole energy content is because of this Cis-Syn-Trans Perhydroanthracene 4A. But initial compound Trans-Syn-Trans Perhydroanthracene 4A have 0 kilocalorie per mole energy content, means it is more stable. And the second conformation after epimerization is Cis-Syn-Trans Perhydroanthracene 4ONE, which having the energy content 2.7 kilocalorie per mole, means higher energy content than the initial Trans-Syn-Trans conformation. Means higher energy content is not possible. Means the lower energy content to higher energy content conversion is not easily takes place, is not easily carried out. Therefore, the epimerization of Trans-Syn-Trans Perhydroanthracene 4ONE into the Cis-Syn-Trans Perhydroanthracene 4ONE under basic condition is not easily takes place, because more stable conformation is never converted into the less stable conformation. Okay, therefore epimerization is not easily takes place. Okay,